Okay, this is Unit 4, Lesson 6, with a little bit of review for Lesson 5, second semester, 7th grade math. What is a linear equation? Who can explain to the class, what is a linear equation? Nicole.
An equation that you can plot on a graph and it be like a straight line.
Okay, so you're partially correct. It's an equation that you can plot on the coordinate plane, and the plot will give you a straight line. But when you say plot, what are we talking about?
Talking about
The points. So we're getting the right track. You're talking about the points. So the points form the graph, but what are the points? Let's think about that. How do you come up with a point?
The point you get them from the equation that you put.
It does come from the equation, but can I just pick any old thing to come up with my point? What do you have to do?
You have to
How would you find a point for, say, number 2?
words and get y into like a straight line.
Right, so how would you find one point for number 2? What would you do? Can somebody help her out, Sophia?
A linear equation is an equation that forms a straight line on a graph or is proportional.
Okay, that's not what I'm looking for. I'm trying to get to how do we find a point on a line? This is what's important because I think you guys missed this. So it was briefly talked about. How do we find a point? Do you just say, hey, I'm going to pick up any old random numbers to come up with these points? No, you use the equation like Nicole said to come up with the points, but how do we come up with each point? Bokar in the back?
So the x always comes first, so you go find a point. If it's like
Yeah, but we don't have any points. We just have an equation. How would I find a point?
you just I forgot what it's called.
Goldus.
The income and the outcome.
Okay, it does have something with the income and the input and the output. Kimberly.
You use the coordinates.
Yep. And the coordinates, yeah, we are going to get some coordinates. But how do we get coordinates? How do we get a point? Jose. Very good. So you substitute a value for x. Does it matter what value we pick for x? No. So we could pick any value for x. But if I pick any value for x, do I get to pick any value for y? No. How do we get the y value? We substitute our x value we chose into the equation, and then we get the y that would make our equation true, right? Right? So that's called a solution. So I want you guys to know the terminology. A linear equation, an equation with solutions, and know this, solutions, know what a solution is, with solutions that when graphed on the coordinate plane form a straight line. So each point is a solution to that equation. Do you understand? And if we had all the solutions to the equation, those infinitely many solutions or many points would form a straight line. Do you guys understand? Are we good? All right. So let's take a look at these 3 graphs. So they want us to find 3 solutions for each equation. Now, for each of these equations, are we all going to have the same solutions? Are we going to have the same 3 solutions? You might if you picked out the same x values and calculated the y values, but it depends on what you chose, right? But remember, there are infinitely many solutions for a linear equation, okay? And it just depends on what you picked for your input. that determines your output. So I'm going to go ahead and do this first linear equation. I'm going to do that in green, and I should have a t-chart. That's the first step. Somebody give me some input and outputs so I can find my solutions. We should always pick the super easiest one when it comes to linear functions. What's the super easy x value to pick? Justin? 0. And if I substitute 0 in, Justin, what do I get for my solution? What do I get for my output? For number 2? 12, right? And that's important because that solution at 0 and 12, that has a special name. What's the name for that? What's the name for that point that for x 0, I get y? Go ahead. Not the starting point. The y-intercept. So my line is going to intersect the y-axis at 0, 12. Okay, can somebody give me another point, another solution? Goldis. 1 and 13. Okay, we can do 1 and 13. What else? Give me some other one. Give me some bigger numbers. Does anybody know where my graph is going to cross the x-axis? Where would my graph cross the x-axis? What would my y have to be for it to cross the x-axis? Think about that. Here's the x-axis down here. Any point on the x-axis, what's my y value? I think I heard it in the back. Who said it? It's 0. So in order for this graph, in order for y to be 0, what would my x have to be? Negative 12, right? So if x is negative 12, wouldn't y be 0? And if you look at negative 12, negative 12, I get 0 over here. Okay, and I'm going to go throw Goldis's point here. Here's 1 and 13. Okay, 1 comma 13. And we can come up with some more points. Can somebody give me another point? What's another point? One more point. It needs to be on my graph, my grid. Pick a point that'll give me something on my grid. Bokar? What is it? Negative 13 for x? Okay, if I'm negative 13, what does that put me at? What's negative 13? Is going to be negative 1. So that would be over here. Okay? If I were to connect these, I'm going to do one more just to fill in like another spot. I'm going to do negative 6. What would negative 6 give me back? Positive 6, right? So at negative 6, I'm at positive 6. Okay, I'm going to draw a line through these points, and look at what I end up with. Okay. Now, if I were to calculate the rise and the run for this equation, let's go from this point right here to this point. What would my run be? Remember, these each represent 2 units, so how many? And I'm going to the right, so what is that, positive or negative? Plus 6. Okay, so I have plus 6. All right, but now I have my rise. What's my rise going to be? What's my rise? It's going to be plus 6 again. So remember slope. My slope equals the rise over the run. In this case, it's going to equal 1. So we have my rise, 6, over my run, 6, equals 1. And 1 I can put in front of my x over here. And then I also have my y-intercept. So let's look at my y-intercept. If you look, and here's my y-intercept. There's my y-intercept. we good? Just some review. Now, let's take a look at my next equation. I'll do this one in blue. First of all, what's the slope of this line?
0.
Not 0.
Negative.
What number is in front of x? 1. So we see right away that these have the same slope, right? Do they have the same y-intercept? No. Where does this one go across the y-axis? -20, right? 0, -20. Very good. So let me go ahead and graph this. And I'll graph this off to the right here, x, y. Can you tell me what is my, give me an input. Well, you already told me the y-intercept is what? 0, -20. Can you give me another point that's going to put me on my graph? So you said if I put in 20 for x, what do I get back? If I put in 20 for x, I get back what? 0? Okay. What else? Can you give me some other points? Yep. If x is 5, y would be -15. Right? 5x 5 minus 20. Positive 5 minus 20, isn't that -15? 5 minus 20, -15. Yep.
For x, that would be 9, and for y, that would be -19.
9
I mean, no, negative.
and 20,
Oh,
so that'd
19.
be,
I said 19.
and that would be a negative what?
1.
Not
said
-1. Oh, 19?
Yeah.
And that would be a -1, yep. Okay, so let's go ahead and grab this, or graph this. At 0, I'm -20. So 0, -20. At 20, I'm 0. Right? So that 20, my output is 0. At 5, my output is -15. So right here. 5, -15. And then I'm just going to use one more spot. 19, -1. Okay, so that's 19, -1. Okay, let me go ahead and draw the line. And then we need to observe some relationship here between these two graphs. What's going on between these two graphs? Who can see it? I heard it. The lines are parallel. Well, that should make sense because isn't slope the steepness of the line? And if they both have the same slope, then don't they have the same steepness? Right? So it would make sense if they both have the same steepness or slope, they would be parallel, except for the difference is where they cross y. Do you guys understand? Now, my last function. What do we know about this last function? How is it different from the first two functions? Bokhar? That's very good, and that's what you should see right away, that you don't see any add or subtract at the end. But what does that mean if you don't see that? Okay, I like that you're talking about the input, if it was sequential and increasing by 1, the output would be geometric and arithmetic. But I want you to think about what we did on Friday. Nicole?
If there's no plus or minus, then it should be multiplication.
Okay, it is a multiplication, 15 times x. Teray? It goes through the origin. Very good. So for number 4, we know that this function, and I'm going to write my input output, my t-chart in red. If I input 0, my output is 0. That's because this function goes through the origin. 0, 0, right? Now, I'm going to go ahead and pick some values that'll give me some outputs that are on my graph? What's one input that will give me an output that's on my grid, my coordinate plane? 1.
Only 2.
So if I input 1, I get back what? 15. What else can I input that will give me negative 1 gives me back what? Negative 15, right? And I'm going to do one more that's not on the grid. How about 2? 30. And what about negative 2? Negative 30. Okay, so at 1, I'm at 15. Okay, here is 15 right here. And I'm going to go ahead and label that 1, comma, 15. And then at negative 1, I'm at negative 15. Let me redo that one. Okay, now if I'm going to draw a line through all of this, here's what I have. It's a very, very steep line, right? Right? Very steep line. And that makes sense because the slope is what? 15, right? Isn't 15 greater than 1? These are all leaning to the right. They're a positive slope. Now the thing about this line right here is if it goes to the origin, what do we call that? What type of relationship is that if it goes to the origin? Proportional. Relationship. And here's something I need you guys to know. This number right here is the proportional constant. And that's the point of lesson 5. There's no book exercise with it. Complete the activities in lesson 5. That'll be on the quiz tomorrow. Okay? Now, if you had a slope that was for a proportional relationship that had a slope of 1/2, your proportional constant would be 0.5 or 5/10. So make it into a number. Okay? All right. If they gave you a fraction result as one of your choices, choose the best answer. But typically, you'll write the proportional constant as an actual decimal number, if not a whole number. Okay? Now, that is lesson 5. Something I want you to realize about proportional relationships. What does 15 over 1 give me? Still gives me 15. What about negative 15 over negative 1? What's that going to give me? Still gives me 15. What about 30 over 2? What's that going to give me? Still 15. What about negative 30 over negative 2? That still gives me 15, just like 15 over 1. So we see that these two things, they're equal, no matter what. Got it? So for a proportional relationship, the ratio of the output over the input is going to be the same equivalent ratio. Got it? That's only true for a proportional relationship. Okay? And now you know what the proportional constant is. It's basically the slope. Okay? The number in front of the x for a proportional relationship. Okay, moving along. Today, for lesson 6, we're going to talk about identifying two nonlinear graphs. Okay? So we're going to look at some nonlinear relationships, and there are two types. What you'll learn: to graph nonlinear relationships. New vocabulary: nonlinear equations. Why learn this? When you kick a ball in the air, the path the ball follows is a curved path called a parabola. A parabola is a relationship that is not linear. A nonlinear equation is an equation whose graph is not a line. So we first learned about linear equations, And when we graphed it, we saw that the graph formed a line, right? Now, you don't need to know what type of equation this is. I'll just tell it to you. It's not going to be on the quiz. This is a quadratic equation, and its graph is a parabola, okay? Later you're going to learn more about quadratic equations, but that's not important now. It's important that you identify what the graph looks like for this type of nonlinear relationship. So what I need you guys to do is take a look at the equation y equals negative x squared. Now, when you simplify that equation for whatever you substitute for x, you have to follow order of operations, and this has been confusing students throughout the day. Please, parentheses, excuse exponents. My dear Aunt Sally. So you take care of the exponent before you do any multiplication. Got it? So if you look at my first input value for x, it's negative 3, right? Now, my equation says negative x to the second. If you see a negative sign in front of a variable, you can make that into multiply by 1, by negative 1. Got it? So one way to think about this, and that's why I wrote the column the way I did, the second column, negative 1 times x to the second power. Got it? So if we substitute for x negative 3, the negative 3 and the exponent have to be dealt with first before I can multiply by negative 1. Are we clear on that? So what's negative 3 to the second power? It's going to be a positive 9 because you're taking negative 3 times a negative 3. This is where a lot of students get tripped up. That gives me back a positive 9. Now that you've eliminated the exponent, positive 9 times negative 1 is... So there's my coordinate. That's my output. I need you to find the rest of these values. So take some time, quickly, quietly, calculate the rest of these outputs.
So basically, if the exponent is odd, then it's a negative.
There is a general rule to think about exponents. You'll get to that eventually. Right now, I want you just to understand mentally what's happening to the signs when I raise it to different exponents. Okay? I see high school students mess up on these. I saw a lot of middle school students mess up on these. It's not tough, but definitely try to crank these out now so we can iron out any misunderstandings. I don't care if you make mistakes now while we're practicing. Tomorrow and the quiz on Friday, it's going to matter. So now I can help iron out any misunderstandings you have. Does everybody at least have the output for x equals negative 2? Who wants to volunteer their answer? Bokar?
So since it's a negative 1, so you do negative 2 times negative 2, which is positive 3.
Right, so you're taking care of negative 2 to the second power, so you multiply negative 2 to itself, and what'd you get back?
Positive 4.
Positive 4, right? So negative 2 to the second power is positive 4. Now we got to do what? Very good. We got to multiply positive 4 times negative 1, and then what'd you get? Multiply. Positive 4 times a negative 1. Negative 4. Okay? Who's got this next one for me? Jonathan Lopez in the back. Very good. It's going to be negative 1. Because negative 1 to the second power is negative 1 times negative 1. And that gives me back what? Positive 1, right? And then I have a positive 1 times the negative 1 in front of it, which is negative 1. Very good. Everybody knows the next one, right? What's the next one going to be? Just going to be 0. How about this one? Who's got this one? Leah. This one is going to be negative 1, because 1 to the second power is just 1, times negative 1, which is negative 1. Who's got this one? Justin. This one will be negative 4, because 2 to the second power is a positive 4. Positive 4 times negative 1 is negative 1, or negative 4, so negative 4 is my output. And the last one, who's got the last one? Zainab, go ahead. Very good. Nope. It's not 3 times 2. Okay, is that what you're thinking? Okay, no, the exponent is how many times do I multiply the base to itself? Okay, so 3 times 3 is what? 9. And so if this is 9, multiply that by -1, and then what do we get back? -9. Do you understand? Okay, so really quickly, let's go ahead and graph this. And at -3, we see we are at -9. So this is -3, -9. Okay, and then at -2, we're at -4. So here we go. Okay, and then at -1, we're at -1. All right, and at 0, we're at the origin. And then something about parabolas is they have symmetry. And so if you notice, it's a mirror image and it's reflected about the y-axis. The y-axis would be the line of symmetry. Does that make sense? So if I was to fold this in half along the y-axis, my points on the left and right side of my parabola would line up. Okay, and the thing about parabolas is they're curved in every spot. Even the places where it looks like it's straight, there's a slight curve to it. So if I was to graph this, it would look like slight curve, and then it would return. Okay, so there we have the parabola. Okay, any questions about that graph? Question? Yes. All right, let's graph this parabola. A little bit different than the last one. Set up your input and output table first. First thing. Set it up. Calculate it, and then we'll talk about it once we graph it. 101. What about the last graph? Work out this one, because I think when you see this one worked out, I think you'll answer your question. Who's got the first output for an input of -3? Who's got it? Goldus.
18.
Positive 18. Because the -3 times the -3, positive 9. 9 times 2, 18. Who's got the next output for an input of 2? X is 2. What's Y? Justin.
8.
Very good. Who's got the next one?
2.
2. Correct. Who's got the next one?
0.
Okay. Who's got the next one? 2, correct. 8, correct. 18, very good. Let's go ahead and graph this. Okay, -3. I'm at 18. Okay, at negative 2, I'm at 8. Okay, at negative 1, I'm at 2. Okay, at 0, I'm at 0, the origin. At 1, I messed up on this graph. That should be negative 1, positive 2. Okay, and then over here, positive 1, positive 2. Okay, and then at 2, I'm at, oops, you know what? Sorry, my scale was right. Yep, my bad. There we go. All right, and then at 2, I'm at 8. And then at 3, I'm at 18. And remember, on a parabola, it's always a continuous curve throughout. My graph, that wasn't really the best parabola. Okay. Okay, and what do we call this graph? Parabola. Okay, now we're going to learn about another type of graph, another type of nonlinear relationship. Now, if I got rid of the absolute value symbols, y equals x, what is that graph? What's the graph of y equals x look like? It's a linear relationship. Y equals x would just be a straight line. But now we have the absolute value signs around x. What does absolute value do to something? Because students confuse this all day long. What does absolute value do, Ben? It makes the number positive. Very good. Students kept messing up. They confuse absolute value with opposites. Opposite is switch it to the different sign. Absolute value is whatever it is, make it a positive number. So for this first, absolute value of negative 3 is what? Positive 3. Absolute value of negative 2 is what? What's the absolute value of negative 1? 1. Absolute value of 0? 0. Absolute value of 1 is 1. Absolute value of 2? 2. Absolute value of 3? 3. Okay. Now, observe the graph. Now keep in mind, the graph of y equals x is a straight line, but the graph of the absolute value of y equals the absolute value of x, watch what happens here. It's not a parabola. Parabola has curves. This one doesn't have curves. So here's what this graph looks like. It's a V. Got it? Let's go ahead and graph this one. Graph that one really quickly. Come up with the values really quickly. Let's do it. Come up with your solutions to this nonlinear relationship so we can graph it. First coordinate, what is it?
6.
Positive 6. Second coordinate? 4. Third coordinate? Absolute value of negative 1 is 1. 1 times 2 is 2. The next one is 0. What's the next one? 2. Next one?
4, 6.
Okay, let's graph it. So at negative 3, I'm at positive 6. At negative 2, I'm at positive 4. At negative 1, I'm at positive 2. And then at 0, I'm at 0, the origin. Okay, at 1, I'm at positive 2. At 2, I'm at 4. And at 3, I'm at 6. Did I mess up?
No, the graph at the bottom, 2, and then 2 again instead of 4. Right there. Down there.
What are you talking about?
Down there,
Oh.
the number line. That's, I'm pretty sure it's supposed to be 4.
All right. Anything else? Are we good? Okay, home stretch. How can you tell whether an equation is linear or nonlinear? Justin.
Well, linear equations, you have solutions and your lines are straight.
All the solutions to the equation form a straight line. If it's nonlinear, all the solutions will not form a straight line, right? Solutions form a straight line. And the opposite of that would be the solutions for a nonlinear relationship or nonlinear equation. They do not form a straight line. So absolute value function, parts of it are straight, but the entire graph is not straight. There's a point of reflection where it flips up. Okay. Really quickly, let's do this. Negative 3 to the second power, what is that? 9. Negative 2 to the second power. 1, 0, 1. Okay, let's go ahead and graph this really quickly. So at negative 3, I'm at 9. At negative 2, I'm at 4. At negative 1, I'm at 1. Then 0. And then we have our line, we have our symmetry again. And this is going to be a parabola. It's going to be a very narrow parabola, but it is still a parabola. Now remember, parabola is always curved in all spots, even when it looks like it's not curved. It's always going to be curved. Makes like a U-shaped. How about this one? What kind of graph is this going to give us? No, it's not linear. It makes like a V. It's the absolute value function. It makes a V, right? So what do we got? Didn't we just do this one?
2, 1, 0, 1, 2, 3.
So negative 3, I'm at 3. Boom. And then 2, 1, 0, and then go in the opposite direction. This is what my graph will look like. Okay. Last but not least, can we go ahead and graph this? Graph each equation using integer values from negative 3 to 3. What do we get? First one, what's it going to be? No, if you look what's happening.
Oh, it's the power of 3.
So that would be a negative 27 times a negative 1. Positive 27. What's the next one going to be? Negative 8 times a negative 1, which is what? Positive 8. Then what? Negative 1. 0.
Negative
Negative 1,
Negative 8.
negative 8.
Negative 27.
Okay, this is called a cubic equation. And if you notice, what's going to happen here is something different. So at negative 3, I'm at 27. Negative 3, and then this is 6. This is it. Okay. And then at negative 2, I'm at 8. Okay. At negative 1, I'm at 1. And then I'm at 0. And then look what happens. At 1, I'm at negative 1. At 2, I'm at negative 8. And at 3, I'm at negative 27.
Very messed up line.
Here it is. Now, the graph of a cubic equation looks like this. Let me see if I can get this to fit. It actually goes like this. Okay. Are we good? All right. That's called a cubic equation.